All right, so for Unit 4, Lesson 2, there's an activity where we're playing the game of war, but with logarithm cards. And so we're just going to take a look at the cards and figure out what they are, what their values are, and then we can look at ordering them from least to greatest, maybe not, we'll see. All right, so if we go down to where I have them printed out, let's just take a look at what are these in exponential form. And so this one would be 2 to the what is equal to 64. And so what is that value? That value is, 6? And then for the next one, we have 2 to the what is equal to 8. So that is 3. Then we have 5 to the what is 1 over 125, or 1/125th. So that would be -3, because remember, a negative gives you a fraction. A negative exponent gives you a fraction, and 5 to the third is 125. So then for this one, we have 5 to the what is 125, so that one's just +3. So these two are actually equivalent. So if we were playing war and those two matched, that would be a tie. All right, the next one, we have 10 to the what is equal to 10, so 10 to the first is equal to 10. Then we have 2 to the what is equal to 1/8. Remember that 2 to the third is 8, and then to make it a fraction, it's negative. So that's a -3 as your exponent. So these two are equivalent. Then you have 10 to the what is equal to 1,000. That's 10 to the third. So that one is also equivalent to those two up there. We have 5 to the what is equal to 1/5. That'll be a -1 because you need to make it a fraction. And 5 to the first is 5. Then we have, so 10 to the what is equal to 10 to the -3. Well, the -3 and the question mark are in the same place, so we know that that's going to be -3 as our exponent. That is something that they like to do on things like SATs. So be paying attention to that. You're looking for where the exponents are equivalent, and then it's just a matter of, well, question mark equals -3. Sometimes that'll be an algebraic expression and you have to solve it. We'll talk more about that later. So then in the next one, we have log base 10 to what power, so the base is 10, to what power is equal to 1/10. And again, we're not changing the base number, so it's a 1, but we're making it a fraction, so it's -1. So then we have 2 to the what is equal to 1. And that one is a little trickier. But that's okay. We're just going to leave that the way it is for now because it's a decimal. It's not a nice whole number like the rest of them have been. Oh, wait, actually, no, it's not. Sorry, I'm a little tired today. That's 0. Anything to the power of 0 is 1. And then for the next one, we have 10 to the what is equal to 10 to the 10th. So what is equal to 10? Or question mark is equal to 10. And then we have log base 5 of 1. So 5 to the what is equal to 1. We just said anything to the power of 0 is 1. Then we have 2 to the what is equal to 0.25. That might be easier if you write that as a fraction. So that would be 1/4. So then you might see, oh, okay, well, 2 to the second is 4. Then we need to make it fraction. So that's going to be -2. Then we have 10 to the what is equal to 1. Again, 10 to the 0. It's going to give you 1. 5 to the what is equal to 0.04. And if we turn that into a fraction, we get 1/25th. Let's see, so 5 question mark equals 1/25. And so we know that 5 squared is 25, but it turns into a fraction, so it's -2. Then we have here, we have 2 to the question mark equals 2 to the 10th. So that question mark is equal to 10. The next one, we have 10 to the what is equal to 0.001. Well, we can change that to a fraction. It might make it easier. So we have 1 over 1,000 because that's 1/1000th. And so we know there are 10 to the third gives us 1,000, and then it's a fraction. So it's -3. And then we have 5 to the what is equal to 5 to the 10th. So question mark is equal to 10. Then we have 10 to the question mark equals 0.01. Well, that's 1/100th. And so we know 10 times 2, 10 squared is 100, but it's a fraction, so it's negative. And then for the next one, we have 2 to the what equals 10. And that one might be a little more challenging because that one is a decimal. And so we're going to pause that one for just a minute. We do know, though, actually, let's say this. We do know that it has to be between 3 and 4. So 3 is less than question mark, which is less than 4, because 2 to the third is 8, which is less than 10. And 2 to the fourth is 16, which is greater than 10. And it's going to be a little closer to 3 than it is to 4. So we'll just hold off on that one as far as comparing values. All right. Log base 2 of 20. We have 2 to the what is equal to 20. And that one we can do similarly to the one we just did. We can say, okay, well, we know that 2 to the fourth is 16 and 2 to the fifth is 32. So it's got to be between 4. Well, it's not going to be equal to. Why did I put that? It's got to be between 4 and 5. And it's going to be closer to the 4 because 20 is closer to 16 than it is to 32. All right, so then the next one, we've got 5 to the what is equal to 10. We can do this one in a similar fashion. We have 5 to the first is equal to 5, and 5 squared is equal to 25. So it's going to be somewhere between 1 and 2, closer to 1 than it is to 2. Then we have 5 to the what is equal to 30. So we know 5 squared is equal to 25, and 5 to the third is equal to 125. So it's going to be somewhere between 2 and 3, but closer to 2 because 30 is closer to 25. And then we have 10 to the what is equal to 20. Again, 10 to the first is equal to 10. 10 squared is equal to 100. So it's somewhere between 1 and 2, but closer to the 1 than the 2. Then we have 2 to the what is equal to 1/5. So we've got, let's see, 2 to the -2 is equal to 1/4, which is a little bigger than 1/5. And then 2 to the -3 is equal to 1/8, which is a little smaller. So it's got to be between -3 and -2. Let's see. We've got 4 more. So we have 10 to the what is equal to 9,000. So we already know that 10 cubed is equal to 1,000. And then 10 to the fourth, I did not write that very well. 10 to the fourth is equal to 10,000. So we know it's between 3 and 4, but closer to the 4 because 9,000 is closer to 10,000. All right, then we have 5 to the what is equal to 1/20th. So again, we do 5 to the negative first is 1/5, which is larger than 1/20th, and then 5 to the negative second, oh wait, I should have done that one. No, that's good, is equal to 1/25th. Sorry, for some reason I was multiplying, not multiplying 2 times 5. That is not what we do. So that's 1/25th, and that is a little smaller than 1/20th. So we know it's going to be somewhere between -2 and -1. All right, and then we have 10 to the what? The question mark equals 1/5. And again, we know that 10 to the -1 is equal to 1/10, which is smaller than 1/5. And then 10 to the 0 is 1, which is greater than 1/5. So we know it's going to be somewhere between -1 and 0. And then we have log base 10. So 10 to the what is equal to 1/2. And so 1/2 is also, so we have 10 to the -1 is equal to 1/10. And 10 to the 0 is equal to 1. So it's somewhere between -1 and 1. But if we compare these two, this one is closer to 1/10, and this one is closer to 1/2. I mean 1, sorry. And so this one is actually larger than the one before it. Okay. So this one's larger. Sorry, I should write that. Not largest. It's just larger than that one. Okay. All right, so let's take a look at the next part of the lesson, 11.3, and this is finding logarithms with a calculator. So now we're going to break out our calculators and learn how to use those. So let's move, I don't know how I did that, sorry about that. Let's move back up to 11.3. Okay. To solve the equation 10 to the m equals 19, Tyler writes the equation in the logarithmic form, m equals log base 10 of 19, then presses the log button on the calculator, enters the number 19, and writes down an approximation of 1.279. Priya follows the same steps on her calculator and writes down 1.27875. Experiment with your calculator until you understand how to evaluate log base 10 of 19. What value do you see on the calculator? So let's break out our calculator. I'm going to use my Desmos scientific calculator. We can also do this with our TI-84s or 83s, 84s, and we'll look at that in class as well. All right, so on here, remember that logarithms are functions, so we need to tap on the function button, that was right here, to be able to get to logarithms, and you can see logarithm right there. Don't mind the other stuff just yet. Okay, so, and the logarithm, when you tap that log button, that is automatically log base 10, right? You need to do something else if you need a different base, but this is log base 10. So when I type in 19, and now I need to go back to that main so that I can get my numbers, I'm going to type in 19, and you can see how it gives the answer, and it takes it to more decimals than Tyler's and Priya's. So ours gives us 1.278753601, right? And so it really just depends on how the calculator is rounding, right? So calculators round differently. All right, so now we're going to express the solution to each equation using a logarithm, and then we're going to be able to approximate it using a calculator. We don't have to use a table anymore. All right, so we have a log base 10 of 24 is equal to m. So we're going to say that m, all right, so again, this is log base 10, so we're good with our log button, and we're just typing in 25. So M is approximately 1.397940009, and you will probably be told on any practice problems or assessment problems how far you need to round if you're giving an approximate value. All right, let's take a look at the next one. Log base 10 of 750 is equal to n. Oh, I didn't type in 750, or write 750. And then, so we're just going to do that. And so n is approximately 2.875. We'll round it there. All right, so then let's take a look at the value of each of these. So we have log of 90, and that's the same thing as log base 10. And we'll round it there. And then 1005, went too far, there we go. 3.0022, because that one rounds up because of the 6. And then we have log of 9. All right, so that is how we would find those values. We didn't estimate each of them before we put it into the calculator, but that's okay. All right, so that is how you can use a calculator to find logs of base 10. And then you have your summary down here if you'd like to review that in a way of reviewing the lesson.